Okay, from Fermat's little theorem, we could work with certain congruences involving exponents when the modulo is a prime, right? So the next kind of reasonable question is, can you handle that for a composite integer instead of prime? And to answer that, we need the following definition. Let's say n is any positive integer. It could be prime or composite, doesn't matter. Then Euler phi function, which is written by phi of n, is defined to be the number of positive integers not exceeding n that are relatively prime to n. Okay, can you see that? So phi of n, it denotes the number of primes, actually relative prime, the number of relative primes to n. So, for example, if n is 2, then it should be 1 because there is only 1 there. How about 3? Then phi of 3 must be 2 because 1 and 2 is a relative prime with 3. But how about 4? Then any positive integer less than 4 is 1, 2, and 3. Among that, only 1 and 3 is a relative prime to 4 because 2 and 4 is not relative prime. So there are only 2 positive integers not exceeding n which are relatively prime to 4. So phi of 4 should be 2. So you can check that way. Okay. So in the following example, you just simply try to calculate the phi of n by checking any non-relative prime numbers less than that given number. So we already checked this much. So how about 5? It should be 4. It's clear. How about 6? Then out of 1 through 5, only 1 and 5 are the only integers which are relative prime with 6. Because 2, 3, 4 is not relatively prime with 6, right? That's clear. How about 7? Phi of 7 should be 6 because all number 1 through 6 are relatively prime with 7. How about 8? 1 through 8, like 1, 3, 5, 7. There are 4 integers are relatively prime with 8. You can see that, right? So please try to find up to this much, right? Up to 30, actually. So we can do that. Then can you find any special patterns here? Okay, especially like when the n is prime and when is composite. Okay, composite means product of what primes? Then even can you see any patterns of phi of n and phi of the prime factors of n? Okay, please try to see that. So the remaining part of this section is just handling these questions.